Hello and welcome back to LeetCoding. Here we discuss problems which are frequently asked in programming interviews and try to build a step-by-step solution to those problems, of course discussing the space and the time complexity. Today we are here with a problem which is from the graph playlist that we are currently working on. There are several playlists that we are maintaining, a stack playlist, a graph playlist, and several others beside the weekly contest. So these playlists are to learn and the weekly contests are to see and check your skills. This video might be a bit longer, so please watch the complete video, and after this there will be an announcement as well. So I would need your suggestions and your help so as to enhance the quality of the content that we are creating for you. Let us jump to the problem statement. The problem is we are given equation of the form a divided by b which is equals to k, and we need to evaluate some queries which will be of the form a divided by c. So let us make this clear with the help of an example. Let us say that if we are given a divided by b equal to 2 and then b divided by c, this is given as 3. Now when we are asked to find a divided by c, can we represent this as a divided by b multiplied by b divided by c? We can do this. This is simple mathematics, and this will turn out to be, because we are given the value of a by b and b by c, it is 2 multiplied by 3 which is equal to 6. So this is how we need to calculate that. But how can we think of it? So if we think this in terms of nodes, let us say that each alphabet I am denoting this with the help of a node of graph. We are given a by b, that is a relation from a to b. So if there's a function f x comma y which is given as x divided by y, there's a relation from x to y. So there's a relation from a to b which is in evaluation as x divided by b, and the value of this is given as 2. So this 2 is being associated with this relation, and this relation is an edge from a to b. Similarly, if we go for b to c, there's an edge and the weight of the edge would be 3. First of all, let us try to create the graph. The graph would be of type string, so it will be a map of type string and a vector of pair of string comma a double. This is the map. This is equation, these are values, and these are queries. Now we are creating the graph, we are creating the edges. Int I equal to 0, I is smaller than e dot size. M of e of I. There's a relation from 0 to 1, that is from a to b. So in e of 0, e of I of 0 it is a, and e of I of 1 it is b. Dot pushback e I 1 and the value. So the value is given in this another vector of double, it is v of I. This way we are done creating the graph. Now we need to find a way to evaluate the queries which are given to us. So if we come here, in the query it is given as we need to evaluate a divided by c. So it is the multiplication of a by b and b by c. So if we find a path from a to c, and in that path the edges are of the weight 2 and 3, we can simply multiply them and get our answer. So had it been a path from a to d, so and this edge was given as 6, so it would be the multiplication of 2, 3 and 6. Let me try to prove this as well. So if we were given a divided by b, we were given b divided by c, and then we were given c divided by d. in order to evaluate a divided by d, that is from a to d, a path, we could have multiplied them all and the answer would have been a divided by d. So this is what we have to do. We need to find a path from a given source to the destination. So these source and destination are given in the queries array. For int I is equal to 0, we are traversing the queries array now. The string source is q of 0 and the destination is q of 1. Now we simply need to find the path. What algorithms can we use here? We can either use a BFS or a DFS. I am going with the DFS one. It will be of type void DFS. It is going to take a source, a destination, then this map, and a visited array. Let us create this as a set of string. Let us keep this as v. This is visited and then two values. Double the answer, that the final answer from A to C, and temp. This will help us evaluating the final answer. If the source is already visited, this source I am keeping as the iterator. I mean, this is the node that on which we are currently on. So if v dot find s is not equal to v dot end, that means we are already, this node is already visited. We need to return in this case. Else we are visiting this, so we need to insert this v dot insert the current node. If the source is equal to the destination, answer is equal to temp and return. Else we need to traverse each of the child of the current node. Auto a belong to m of s. This is the simple DFS that I'm writing here. DFS a dot first string d m v and answer and temp. So we need to change this temp as temp multiplied by a dot second. What we are doing over here is we are backtracking here. So what instead we could have done is we could have stored the value of temp in another temporary variable and then changed temp as temp multiplied by a dot second and passed temp here. Then again we can change temp for the next recursive call. So for the next iteration I'm going to make the temp as temp1 again. So this is the backtracking part. Now instead of writing this entire thing, we could simply write temp multiplied by a dot second. Okay, so we are done with the DFS part. We just need to apply it and get the required answer. We need to return a vector of double. So let us create that first. Vector of double answer. I think at the end of each video lecture I should provide certain problems which are on the similar lines, and then you can go and solve them by yourself so as to practice. So from the next time I'm going to find some similar problems and then provide them in the description box. So we need to apply the DFS now. DFS from the start to the destination, and pass the map, pass the visited array, and then pass the answer, and then a temporary variable which is 1 initially. Let me tell you why is it 1. Before that, a set of visited, a set of type string visited that we are passing here, and answer is going to be -1. Answer should be passed as a reference. Now, what is this temporary variable for? This temporary variable is initially 1. If we are finding a path from A to D, we will be traversing from A to B, and we will be multiplying 2 to the temp. Temp will now become 2. Then from B to C, when we go, we will multiply 3 to the temp, and now the temp will be 2 multiplied by 3, which is equal to 6. The value of the temp is 6. When we are traversing from C to D, the edge is of the weight 6, so 6 will be multiplied to this temp, and it will be 6 multiplied by 6, which is 36. Now when we reach destination, then we are going to set our answer as this temp. So that is what we are doing here. When we reach the destination in the DFS call, if source is equal to destination, we simply need to make our answer as the temporary variable and then return. As simple as that. Now we are pushing back the answer after the DFS traversal. Answer dot, let us make this result, because we are using answer inside our for each loop, our for loop for the queries. So answer result dot pushback. Result dot pushback answer, and then finally return return the result. Let us try to run this. This is TMP, it should be TEMP, temp. No variable conversion from line number 35. String s q of 0. It should be q of I of 0 and q of I of 1. So we are getting wrong answer for few of the cases. Let us try to handle them one by one. So for the last case, the answer is 1. It should be -1. Why is it 1 for the last case? That is because the edges that we are given here is, let us try to make the graph first. Increasing the font size. Okay, now we can create the graph. A, B and C. From A to B, the relation is 2. The weight of the relation is 2. From B to C, it is 3. We are asked to find from A to C, which is 2 multiplied by 3 is 6. We are getting this as correct. Then from B to A, because from B to A there is no path, the answer in our solution is -1, but it should be something else. We are going to handle this a bit later. Then we have from A to E, because E is not present, it should return -1, and it is returning -1. From A to A, it should return 1. From X to X, it should return minus 1 in this case because x is not present. So first let us handle the cases which are not present. If m dot find the start is not equal to m dot end, then only we need to call the BFS function. If the start node is present, then only call the DFS function. That way we handled the last case. Now we are left with the case number 2. In the case 2, the answer should have been 0.5, but the answer is -1 in our case because there's no path from B to A. But if a relation is of division type, so if A divided by B is given, B divided by A could be obtained. Actually, A by B is same as 1 divided by B by A, and vice versa. So if we have B by A, we can obtain A by B. If we have A by B, we can obtain B by A by simply doing 1 divided by A by B. So these both should be handled in our map. There should be a relation from A to B and from B to A as well. But when we are creating a relation from B to A, we should create this as 1 divided by the edge weight. So this is handling the relation from A to B as well as from B to A. So this is actually forming the complete graph. Okay, it should be 1 and it should be 0. This is now completing the graph and it is going to answer each of our queries. Let's try to submit this. It got accepted. Now let us talk about the space and the time complexity. After that we will be discussing something about the channel. So this E, which is the number of equations, let us say the size of this is m and there are queries, there are, let's say, n queries. If E is given as m, we will have 2 into m edges. We know that the time complexity of a DFS is E plus V, big O of E plus V, where V is the number of edges. In worst case, V could be as large as n square, where n is the size of the number of nodes. So if the number of the node is represented by V, E could be as large as V square. So if the size is given as m, the complexity will become big O of m in worst case, and this DFS function is being called n times, so it will be big O of n into m. This is the time complexity. Talking about the space complexity, first of all, whatever we are using here, if whether it is a map or it is a set of string, we should declare this as unordered so that we have a constant time complexity. Now talking about the space complexity, we are using map here, big O of n, where n is the number of nodes, or I should rather say big O of V, where V is the number of nodes. So this is the space complexity. Now talking about the channel, we are creating separate playlist. So first I thought of going in a company wise manner, so creating the company playlist such as Microsoft, Amazon, Google, Uber, Facebook. First I created these playlists, but now I'm thinking of making the playlist according to the topic. So now we have a stack playlist, a graph playlist, and I'm thinking to create another linked list playlist. So please suggest me that which method is better for you to utilize these videos, whether they should be in a company wise manner or they should be in a topic wise manner. For me it matters because when I'm creating certain videos, I have a mindset that I'm creating this video for graph or I'm creating this for a specific company. So that's how I proceed when I'm creating this playlist. Each week I will be focusing on a particular playlist and try to provide 2 or 3 videos to that playlist, and then we will move on to the next one. This is what we are doing. Parallel to this, we will be uploading the solution to the a weekly contest and bi-weekly contest as well, but this is the main focus as of now, so that you can learn from this and then you can perform well in the contest as well as in the company interviews. So please provide your suggestions in the description box. Thank you.